Let's take a look at this problem. Suppose that someone asked me to find the greatest common factor of 450 and 315. So here, this word factor means things that multiply together to make up. For example, 36 is 2 times 18, so 2 and 18 are factors of 36. 36 is also 4 times 9, so 4 and 9 are factors of 36. And in fact, instead of trying to come up with all of these pairs, it's easier to write this as a prime factorization. 36 is 2 squared times 3 squared. So remember, primes are those numbers, whole numbers greater than 1, whose only factors are 1 in themselves. And to write the prime factorization then is to break down a number into just a product of primes. So what I want to do to find the greatest common factor of these guys is I'm going to write them both as their prime factorizations, and then I'm going to use those to pick the largest values that appear in both. So let me clear this out of the way here. I'll be honest, I just did this video, but I wrote something down wrong, so I'm doing it again. I hope I get it this time. So if I want to write the prime factorization of 450, I can use one of those factor tree things, right? I can just break this down into two numbers that multiply together to be 450 and keep breaking those numbers down until I'm left with just primes. 450 is perhaps 45 times 10. Neither of those is prime because I can see 45 is 5 times 9. Now notice that 5 is prime. 9 is 3 times 3. Remember that 3 is prime. And 10 is 2 times 5, and both of those are prime. So if I put that all together, I have a 2, I have a 3 squared, and I have a 5 squared. So 450 is 2 times 3 squared times 5 squared. Okay, let's do the same thing to 315. So 315, I'm not exactly sure what that's divisible by, but I know it must be divisible by 5. 5 goes into 36 times, into 15 3 times, so I think it's 5 times 63. Double check, that would be 15 plus 300. Great. 5 is prime. 63 is, how about 9 times 7? And 9 is, I'm going to say, 3 times 3. Remember, I don't want to put 1 times 9 down there because 1 isn't a number in contention because it's not a prime or composite number. And I don't make any headway by writing down 1 times 9. It's better to break it down into pieces. So 315 is 3 squared times 5 times 7. Now, if I look at those two prime factorizations, notice they each have a 3 and it's to the second power, so 3 squared. And then notice they each have a 5, but only this one has a 5 squared. This only has a 5. I can only take the 5, and the very obvious reason, or the reason that it should be obvious is 5 squared is 25. You can't divide 315 by 25. It's not divisible by it, so it can't be a factor of it, so it can't be the greatest common factor. So the greatest common factor of these two numbers is 3 squared times 5. We sometimes abbreviate this as GCF. And 3 squared times 5 is 9 times 5, or 45. So the greatest common factor of 450 and 315 is 45.